Now it's time to introduce dictionaries. So let's look at a data structure that defines or allows us to visualize what a dictionary looks like. The important part about this is I want you to notice the pair components that make up this structure. So let's call this one dict1, our variable dictionary one, and we're going to put curly braces just like we've done prior to this with sets, except we're going to specify, and it's going to be a custom kind of an index as to where an item is. So for example, I could say 0 is my index, colon, and then I can put the element or the content where I want there. Let's say we put Henry. And then if you want another element, then you will have to specify its index. Now I'm putting a numerical value. I'll show you, you don't have to do that, and it doesn't have to be in any order. However, each one of these will have to be unique. So let's say 1 will be Ford, and then we'll put a comma at the end of that. Okay? And let's go ahead and do 2, and let's give Henry Ford an age. And it doesn't have to be a string. If it's an age, we're going to do average ages of a set of dictionaries. No big deal. So let's give him 78 for now. So there you have it. Notice that squiggly line is just a matter of formatting here. It really isn't that big of a deal. You can have these next to each other. The delineator will be the colon, so you're good to go. Now, how do we access any of these members? Now, just like we've done with, let's say, a list item, we've used the index. So we have a custom-made index that we defined that 0 would have Henry, page 0. Page 1 will have Ford. Page 2 will have the age 78. So for printing purposes, we could do something like this. Full name and comma, dict1, and then guess what? At index 0, comma, dict1, which is the variable dictionary type, and that would be at index 1, right? And then we could do print age equals, and then comma here, dict1, and then between brackets, that would be number 2. Let's see how this behaves. And there you have it. So it will look at each one, right? This represents index 0, so give me the content, which is Henry. This represents index 1, which is this one. Okay. Now, does it have to be, again, in the order 0, 1, 2? So let's put another number here, 9. And now if we try to work with this, we're going to get an error. There is no such thing as 0. So let's see here. There you have it. So key error. So these are keys when you're dealing with dictionaries. Okay, we called it an index, but the true definition for it isn't key. Now, what if we use 9? Okay, well, let's see what happens here. Not a problem. We're back in the same position. Now, what if we duplicate a key? Let's put 2 9s in here. That will create an error. You cannot have duplicate keys. Okay, all right, so let's put 0 in there, and let's put 0 here. As I said before, no specific order. You could do whatever you want. Does it have to be a number? No. You could do something like this. Age. Aha. You could be very specific as to what the key is. In that case, type age here to identify the element 78 as that. Now, be careful here. That is not a variable, so we're going to do this. Right, so it is a string literal age. So let's see what happens here. And then we're back in business. Now, what if we had, again, let's see, first here, as a string, and last here as a string. So now your keys are much more precise as to what they represent instead of being a number like an index. So you could have first here, oops, it has to be a string obviously, first and last. So this is the basics for being able to utilize a dictionary. Okay, we're going to be looking at more details in terms of dictionary in our next steps or next parts, where we're going to be changing items, adding, removing items, looping through items, and then we're going to look at some special methods associated with this data structure. I will see you then.